All right, these take a little longer. These are pre-calculus. Pre-calculus is actually a very hard class to teach for anybody who's watching this that's not a student or maybe wants to come back and teach at West Point. It's not a fun thing to do because it's a bunch of methods. But all right, here I graph this on Desmos. I see that there's an asymptote here. I can kind of guess that the asymptote is probably at 6 because x equals 6 makes this 0. The negative exponent actually, one of the most powerful laws to remember as a pre-calc student is the fact that x raised to the minus m is really the same thing as 1 divided by x down. I don't know why it's jumping out of the equation editor, but there we go. So that rule tells you that really this junk here is kicked downstairs. And if you have a fraction like this, you can see when x equals 0 in this, you're going to have an asymptote. So here it's shifted by 6. You're going to have an asymptote at 6. But I haven't punched this into Mathematica. Let's see what Mathematica tells us. So we put 17, x minus 6, and then we put minus 2 here, and then we put plus 10. Let's see what it does. And it gives me this weird thing. It gives me this x is less than 6, and the double lines mean and x is bigger than 6. What that's telling me, this double line is saying x is less than 6 and x is bigger than 6, or x is bigger than 6. Sorry, this is or. I have to go back and look at it. This is or x is bigger than 6. That's a union if we want to put it in interval notation. These double lines mean union. So if I'm going to rewrite this into WebAssign, what I would put is I would put x is less than 6 would come first. So that would be from minus infinity to 6. And sometimes I have you draw the intervals. That would be a good thing to do right here, actually. My pen is not working on 6. Union. So here's a union. That's the up cup. 6 and infinity. I don't know where everything disappeared to. Let me see. There we go. Basic math, infinity. So that's how you express your answer eliminating 6. And this is how Mathematica does it. You need to be able to interpret Mathematica. Second one, range. Well, that's easy. Let's copy paste and dump it into here and see what happens. Y is bigger than 10. Easy peasy. So let's go over here and type that in. That's going to be insert a equation. Y is bigger than 10. It was not it was open. So 10 to infinity. It did not include 10. So there we go. That's the range. And I can see that here. So that must mean this line here is 10. And everything below 10 is okay for the range. Everything above 10 is not. And so there we have the 10, or bigger than 10. 10 is not included. It's what we call horizontal asymptote. Let's do one more. Here I have, this is one, it's still number 1. If I go into Desmos and plot it, I see there's an asymptote right at 4. You see this -3. As I mentioned, that kicks it down to the basement. Let's see what Mathematica will give us if we type this in. We get 16 here, x minus 4, get a -3, plus 9, shift enter. And you see again something similar to what we had before. Up to 4 is okay. up to after 4 is also okay. So I'm just actually going to, because I don't want to type everything again, I'm just going to copy this, paste it into here, and then this is how I write it. I'm big on copy paste, but I have a lot of copy paste errors as well. So be careful imitating me. Let's go down to Mathematica and put that into the range function. We can already see what the range is going to be. That's why I always recommend drawing your graph at the same time, so you can see and compare. What does it say? It's screaming at me for something. Oh, I have an extra comma. All right, so here we have something different than before. We have y is less than 9, not including 9, and then y is bigger than 9. So if I go over to the graph, what that's saying is not this horizontal asymptote is at 9. It will never be touched. So anything below 9 is okay. Anything above 9 is going to be included. So I will have, if I want to graph that in, this is what's going to happen. I'm going to have 9 here and 9 here for the range. And so let me make sure that this is put in here so that you see that how to interpret the output. So I just want to make a comment of Stephen Wolfram, Dr. Wolfram. He's actually using language that's from computer science. He was trained as a physicist, and he's doing pre-calculus, automating it. Pretty amazing how he stepped over so many different disciplines in our language. But this is the Mathematica output. This is how to interpret it and transfer it to our mathematical notation that we expect from you.